Can you all see the slides?
Yes, I can see all that.
Super, thank you very much. Firstly, thanks for having us on to Medland's LabVIEW user group. Obviously good to see some faces. Shame it was in person, but good to have it online, which is good. I thought I'd just do a couple of slides. The slides have to be approved by corporate, which means there are a couple of standard sort of company intros. It's quite good. I tried to limit them from a slide pack of 24 down to 4. That was the least I could get away with. So Graphic's been around for about 5 years now. The goal is to do graphene electronics, and we've got a couple of sites now, and we're really starting to build up capability. The timeline is pretty good. We sort of kicked off from Cambridge. I've been now with the company just under 4 years. So I came in when they started doing Hall sensors, which is the main product and where the sort of most of the presentation materials come from. So sort of 2020 to 2022, behind the scenes was all on the Hall sensor, which meant we started delivering product and kit with acquisition units to customers in sort of 2023, which is the main one. And then as of this week, we released a GFET based on graphene. So that's quite new to sort of the world. There are some people doing it already, but we're definitely starting to lead that going forwards, which is great. Obviously, with every new product, as Craig alluded to, there is test. And there's more test and there's more test. So obviously, as you grow your products, as you grow your capability, your test should grow exponentially. So the challenge for me and a few others here is to sort of try and keep up with that. And that's really where this sort of idea of LabVIEW glue comes together. We use LabVIEW generally for the very, very fast, rapid prototyping to do initial one-offs, very small applications, which in sort of my experience has always been the really bread and butter of LabVIEW, which is really good. We've got the 3 main technologies. We've got the Hall effect sensor, GFETs, and then sort of custom. The main one is the graphene, and marketing our lovely slide with animation. I don't know how long it took him to do it, but you know, it's always good. It's nice. So you've got a simple Hall cross, which is great. You then apply magnetic fields. You can look at the difference on the voltage if you're under current control, which give you some differences, which is great. You can start measuring the magnetic field, which is good. So not long after I first started, I'd been here about a month, and someone said, I've got a probe, and I pick it up and I move it around. I've got a little couple of calibers, but it takes a long time. Can we just have a small application that moves the probe around? So I sort of went on to Zeta Stages, who I've used before in the past, and went, if you buy one of these, it'll probably work. So I went on holiday for a couple of weeks, came back, and there was a pile of boxes on my desk. I thought, I wonder what that is. And they'd gone and bought the Zeta Stages and went, oh, we need this. So it sort of went backwards, because normally, as we all know, you should make requirements, and then you spec the kit, and then you make the software. So this was a slightly different approach to what you sometimes do. And then they said, well, when can it be ready? And I was like, well, it shouldn't be too long. And they're like, well, we need it in a couple of weeks. So obviously that's fairly aggressive, but you know, we sort of made it, and it moves around and it puts the probe down. And we didn't break lots of wafers and trash the place. So that was an advantage. So that went really well. And, you know, we sort of got the job, as they say. And then sort of not too long after that, we had another one. Can't we just have something to switch a wire around? So this is what we call Hall Kit A. So when the wafers are taken from the reactors, sometimes they're reference wafers, so we chop them up into a little square, and they're put on a little probe plate manually, and then you'll see there's a key flea in the bottom right, and these wires are then sort of pumped around, and there's sort of 12 different combinations. It's like one of those old telephone switch boxes with a good old banana plates going out and in. And the poor guy was doing this all day, and he said, you know, it's got to be a better way. So can we just have something to switch a wire around? And we went, well, yeah, of course. So we got sort of modular switch box. They'd already got a key flea, so we got a source meter. I've made the UI quite small. I know the audience here is pretty technical, so I wanted to sort of take away the fact there's a lot of buttons on there, there's a lot of drop downs. But then this was build more at researchers. This is sort of the flip side of what Craig was sort of dealing with a user-defined group that's very big. You've got a very defined sort of sequence, as you would call it, very fine configuration. This was the other way. This was a team of researchers wanting to do everything a Keithley could do, which is basically from 0 volts up to 200 volts, and from about 2 nanoamps up to a couple of amps. So the old auto ranging comes into play pretty handy. So we've tried to utilize the kit where possible, obviously. It has meant there's a lot more configuration on the front panel. As you can see from the UI in the bottom left, just about with the 4 pixels, it's very busy. But on the flip side, we haven't had to rebuild it too much. We've exposed everything at day one. It is hard for when someone starts, because they're like, well, what do I set everything to? And you go, well, what do you want to set it to? Which sort of leads into a circular argument of what should we put it to? And then we go and have a coffee, and then we work out what we did last time. which is always the way. So this is great, and that provided lots of information. So we've got one little application that's sort of doing the standard sort of stuff. And they went, yeah, but on this one, we have to manually move the magnet in, and then we have to move it back out again. So they went, well, can't we just have something that moves a magnet around? So by then we had a few more people, which is great. And then we sort of, me and a couple of other people built a sort of linear rig, as we call it, which is this linear motion of moving the magnets. Before we used a big C-shaped magnet, very heavy, quite cumbersome to move, quite slow. This we can accelerate the magnets quite quickly. We can move it forwards and backwards, and we can sweep the magnets through the magnetic field of interest next to the sensor. But it wasn't just that they wanted to do. It was, well, how many do you think you might need? We don't really know. Oh, we might have another one this month. We might need 3 next month. So suddenly we're like, okay, the alarms start ringing. So obviously, standard build, rack mounted, reusable parts, common components, UPS for backup, environmental logging all came in at this stage. So this is Hall Kit B. So this was sort of a good upgrade. I mean, it's pretty decent, but still didn't really have the capacity. Then we started putting more sensors on each wafer. At this stage, we were doing 60 per wafer. So a couple of minutes of Hall test, a couple of hours you get through. And then the company went, well, we have to scale up. This is part of the company's growth. In 2022, it was, we now have smaller sensors. Okay, so how many are we going to have on a wafer? And someone went, oh, just about 1,200, which is quite a step up. So when you do 1,200 times 2 minutes, you end up at about a week and a half, which apparently is not good for throughput. So then it was, well, can't we just do a whole wafer? So a couple of coffees, cans of Coke, and sort of a morning in a room, not let out. We came up with this. So this was done just before Christmas of that year. And this was sort of the original sort of concept. And then basically by the end of March, we had it running. So this is sort of what we call the full-on blown prober, which is a little bit more. So we've still got the same principle. We need to switch the wire around, but we have got a switch card in the top right. So that's a 24/8 matrix, which allows us to do some funky stuff. Is this going to be used just by research? Don't think so. I'll have to go into the main lab. So you need CE certified? Yep. Do you need the full safety? Yep. Okay, so we have to do all that. And that was great because it meant we went from sort of, testing 2 minutes a device to we could do it in under 20 seconds a device. It had to be fully automated, so someone could load a wafer in, scan the barcode of the wafer, put it in, a couple of minutes for setup, shut the door and press go. And then in under 8 hours, we've done 1,200 devices. That's been in for quite a while. It's running throughput, it's pretty good. And there has been some things we learned. However, in the meantime, we got another couple of ones. Well, what if we just made the pad smaller? So bearing in mind, we're already at about 80 microns square per pin. What if there's about 20? Is that going to cause a problem? We're like, well, a little bit, because that's the core of the area. So we really need to sort of, get a bit more quality in there. Fortunately, stages we got are under a micron control accuracy. So it really does go with get something over-engineered at the start. Spending an extra couple of thousand on stages that have got very good repeatability, very good accuracy, picking a range where they do every single distance, every resolution, comes back in so much. If you just go for that company that only supply one thing, you can't switch. The driver's the same for the whole range. As long as you specify whether it's Ethernet or USB, you're pretty much in. Everything's the same. So working with Zaba, we've managed to sort of utilize pretty much one of every one from every page of their website. So they're really pleased with us because we bought loads, which is good. So we've got a decent link up with them. We've still got the Keithley in there. We've still got the switch box, and we've still got the stages we used on the original sort of probing part. So really, we've gone from the basic one of just moving the probe. Then we've gone, well, can't we just switch the wires, and then can't we do the whole thing in one go, which is quite cool. So that was good fun. And then this is sort of displays sort of what it meant to the business in terms of the company. Before full automation, we had a wafer with the 1,200 devices. It would be standing device, comes up back into build, and we'd probably only build 3% of the wafer, just from a time point of view. You can see there that you're at 2 weeks generally. These are all very average and abstracted to ensure people can't see how much we're pushing through. That was one of my first round of slides. It was slightly tweaked. But you can see that you got 2 weeks from the start. By putting this bit of kit in and sort of using the knowledge we used before, we've now got 100% on all the properties rather than some, and we get it a day after completion of front end line. So effectively now our DOE is now not waiting for the results. So we're able to now pummel this ridiculous. So our feedback loop for the business has gone through the roof. which has meant that it's been under massive strain and it's been used and hammered more than we thought. And everyone goes, well, can we change the sequence? Yes, because we can put in a sequence configurator at the beginning. It's crude and it's not anywhere expensive. It's not as good as Greg's. I'll be quite honest. It's nowhere near the quality of the sequencing, but we've still got the fundamentals if we can change it. We can do some dynamic calling. We've got some flow control, which allows us to abort and stop and make some decisions that we don't stop. So that's been really useful. And it's a good example of, rapid deployment, rapid thing, and it pays back within a couple of months, which is great. What we get out of it's quite cool. We've got the top right, which is a LabVIEW VI. It's sort of zoomed out a little bit. You can sort of see that we've got one massive table. As you can see, my UI is not my strong point. It's all in grey, it's all in boxes and with tables, but we're not going to external customers. So the UI design is not quite as critical. The the experience, hopefully, is a solid part. So you can see there that we've got the zoned in sort of data structure that we bring into our stats software here in the business. And you can see the little devices. You can see on the zoomed out one on the left that it's quite sort of zoomed out. Then we go to the sort of medium, and this is the sort of level, and you can just see, hopefully, the pin marks where we've just touched down. Just about, maybe a couple of heads nodding, squinting, glancing at the screen. So to give context, that's a 20 micron pad size, and we've got a working range of 20 microns on the Z. Either we own the probe and over probe, so we're dealing pretty tight tolerances. And that wasn't in the spec, funny enough. That was, can we just probe it? So we didn't actually have that as the first requirement. So we've had to sort of back calculate a little bit on that one. It's quite nice because the data comes through in real time over the 8 hours. So we can sort of pick and choose the sequence. We can random top and bottom and do some sort of pseudo random stats through the wafer. So we're not just going from top to bottom. We can actually sort of pick it up, abort the test and stuff. Because the data comes through in the SQL side, we've got other applications that's picking up. So it's all real time. So the machine is sort of just sitting there in the lab running away. So everyone can sit in the office, have a coffee, chill out, watch the data come through, which has gone down well with the scientists. Then IT obviously wanted to know what applications we were running on all the different things. And there's some nice stuff on Twitter with different people. It's always good to follow to pick up some bits. I'm sure most people are probably aware of this one. This gives you an option to sort of pump it into the Windows system log. It's great because that helps us with IT, because obviously when there's an issue, they'll always blame the in-house software, because that's the one that's always at risk. So that gives us some credibility. If there's a problem with the PC and the event log is clean and I'm not there, then obviously I relax, I can walk away, which is great. But it's good from a traceability point of view and to get some stats off the IT stuff here. Then they were like, oh, it's taken 8 hours now. Can't we just have some sort of alert? So when we put this back in the first one, obviously the UI person's not always there. The PCSP locked. Beacon, it's a bit sort of 80s, isn't it, with a traffic light? SMS, no, we don't want to use that. Email gets lost. So I know if you've used the Teams webhook, which is really useful. It recently changed. You can app people now, which is great. So now it's whoever starts the test gets the message with an app, which is very powerful because it means everyone can subscribe up to the group or the Teams channel and then only get notifications on who's actually running the test, which is important because then people can pick up the message direct, and it saves you having a Teams channel for every single person, so you can be a bit more dynamic. You can put a lot more in the V cards now. They're much more generous in what they expose. You form the string, you push it through on the format, as long as you've got the format correct. And this works outside the SQL interface and infrastructure we have here. So we just use it as the web base. So we're not limited to using it just on site. So if we, have got stuff sitting off site, we can actually get data back from the field. If we're testing at other people, as long as we're on their guest Wi-Fi, we actually then pull back some of the stuff quite easily, just to say it's happened. Just put a table of numbers in, just some summary tables. We know when our suppliers are doing stuff as well without having a massive infrastructure put in. So we're trying not to snoop. We're trying to work with people to collect data in a sort of nice way, which is obviously really good. And the app is very, very useful. So we use the Teams alert. Before we had Jira, which obviously you could interact with a lot nicer. It was a way of us. Some of the applications had little help buttons that created a Teams alert so someone could write something in as a little message. So it's a very crude way of making sort of a ticketing style help system. And we've used it a lot. There's a lot of cheap channels here. Plus, people can reply to the Teams channel. We have different alerts. If errors and hardware alerts, they can alert the Teams group and we can manage it because someone then picks it up. So it's a very crude way. And everyone's got Teams. So effectively, it's a free platform. which is great.
Ben,
Then
on
there
that
was,
one,
sorry.
just a quick question, if you're all right. Is that all the code you need to send a message to Teams, or is there more to it than what you've got on the screen there?
So where I've written vcard in the string constant, that's what the text on the right is.
Okay, yeah.
And you also need the webhook, which is the bit there, which is normally about a 50 alphanumeric thing that you get from Teams, and you drop it in. It's really quite simple. There's also there's a PyTeams as well, so you can use it across language, and it's the same thing into a webhook. You're just basically effectively building the JSON formatted string, which you push onto the buffer and then post. So it's all pretty simple. Yeah, it's quite handy. We're not allowed phones or anything in our lab, so people have their smart watch, which connects to the MDM policy phone, which is outside the lab, so they get a notification on their watch, which is quite nice.
Cool.
Yeah, which is nice. Then it's like, oh, we need an image. We sometimes use a microscope camera to align some of the images, but you can't plug it in because it's not certified with IT, because that's got firmware and all the things that go around there. So we ended up putting in an HDMI to USB, which is really crude, because you go from the camera, which has got USB and HDMI output, and then you go HDMI and then you go back to USB, which I thought was a bit silly, because you've still got USB, but you are protected from, in terms of IT and infrastructure security. So for cyber essentials and obviously things like that, the risk via HDMI is very, very low. Obviously plugging in a camera that happened to be sitting in a lab and no one really knows where it came from, that's running firmware, and plugging into main PCs, obviously is a little bit dangerous. So that's a bit ironic. I found that quite funny, but then my sense of humor is a bit different. Then it was like, oh, we wanted the camera, we only wanted the image, but then we want to control it, but there's a mouse. Well, that becomes really tricky, because we've now got no control because we've taken away the USB. So most of the Arduino boards can become an HID. So you can actually create code on the Arduino to drive the mouse around, which is really crazy, and you shouldn't be doing this in terms of long-term infrastructure. We now have cameras with comms, but initially, when we didn't have the ability to buy the high-spec cameras with the comms layer and the Gigi interface and everything that you would expect to have, when it's literally got a button, you just got to click autofocus. So there's an Arduino that was running on one of the old rigs that had a digital input that we could trigger through a LabJack T7. So we had some of the stuff that Craig's using well. That can trigger a mouse event via an Arduino, which then triggers the event and clicks the camera. So it's an automated mouse clicker. It works with Windows as well, which is quite handy. So for 10 quid, you can effectively have an automated mouse. If you change it to serial, obviously you can program in whatever you wanted to. It also works with keyboards as well. So for legacy old kit for doing some interaction, it's almost like an automatic button pressure. So that's quite fun. You can also do the flip side. I don't know if people have used this before. You can control Windows keyboard and mouse via LabVIEW via Windows. This is great for controlling applications where you have to sort of programmatically do things. I also use it for testing some of my UIs as well. So I automatically kick through the buttons and take a screenshot to ensure. I mean, there's lots of test programs, Test Complete. Obviously, there's loads of different ones out there. The nice thing about this is, because it's a hybrid one, you can do other events at the same time. So you can check that files are being written. You can check on your interface that things have happened. So having the mouse control under LabVIEW is really quite nice. There's keyboard as well, which is nice. So you can see I got Control C. You can copy, you can paste, you can use the clipboard, which is really good. Obviously, consider how you take back control. Once you start your application, you've lost it. Basically, you've got to have a way to get out. How do you stop the application? That caught me out very early days. So now I check on the mouse position move, and I retain my previous position move. So if I've moved the mouse, the software knows then you've moved it and it needs to be stopped. So yeah, that makes it a little bit better. So they're quite good fun things. So where are we now after Can We Just Have? This is our sort of in-house launcher screen. We've now got a whole group of software tools. The majority are built on LabVIEW. We do use other scripting within the business, quite funny enough. So we've now got sort of 35 what we call mainstream released applications used by about 80 employees around the company. The software's grown organically, which is good and bad, as we all know. If we know what we're doing at the start, you get a better solution. You know what you can do, and you can spec the hardware accordingly. We're now moving into full requirements, but we're able to do that because we've got very good proof of concept. So it's allowed us the full understanding of what we actually need as a business. And LabVIEW's been a core part of that for the rapid deployment. So generally, we've got reasonable hardware already because the research scientists are using high-spec stuff. So we're fortunate from that point of view. And then we've been able to build on the software on a lot of different areas. And even some of the applications are very small, where it's taking files from equipment that is not connected, parsing the data, pushing it to the database, and vice versa. Some equipment has really nice interfaces and drivers, like we all know. And when you open up the driver and it's all there and the BI tree is perfect and the example works straight out the can, you sort of have that sigh of relief and it's all working. But not every case is like that. So you always have a few edge cases. So we've ended up with quite a few tools that we use in day-to-day. LabVIEW's obviously good at that. To me, that's his core thing. You know, the data acquisition side, visual display, rapid deployment is where it comes off, which is good. I think that's the last one. Thanks for your time. Thanks for presenting. I know I'm the last one, so I've tried to go really quick to ensure that we all get away early and all that. Yeah, any questions, welcome to ask away.
Nice, Ben. Thanks very much.